A couple of years ago, when people were trying to get ahead forward of edge computing, there was a chicken egg problem where people did not have proper edge infrastructure to create edge applications. There was no proper edge native applications to create a proper relying edge infrastructure. Not so long ago, a team from Carnegie Mellon University created something called JIT Cloudlets, which uses common off-the-shelf components which are open source and created this amazing architecture for edge native applications. This semester, we worked on a couple of applications that leverages this JIT Cloudlet, and it's a testimony of how easier it is to create edge native applications which works on top of this JIT Cloudlets. So we assumed to main a theme which is a music festival, and we created two applications for it. The first application is a chat bot which has two LLMs in its backend, and the second application is a caricature. It's basically a style transfer algorithm which just takes a user input and tries to create a real-time caricature of the person who's in the frame. Now, circling back to the first application, it runs two LLMs. The first LLM is the Godel model, which is a Microsoft model, which is open source, which is specifically designed to fine-tune it for a specific task, such as answering questions based on a music festival. And the second one is a GPT-35 Turbo model, which is backing up the infamous Chat GPT. The thing with the GPT-35 Turbo model is that not ideal because it has to be relying on an internet connection. The thing with the Godel model is that it can still perform better, but and perform locally, and it's still within the cloud. The main innovation part of this cloud infrastructure is that we have the embeddings within the cloudlet, which means we are preserving the privacy of the data. What goes to the third-party enterprise API is just the vector and embedding part of it, and that's the cool part of our architecture. And we also have a fallback local LLM when we don't have internet connection, which can be leveraged to be as good as the GPT-35 Turbo model. And coming back to the caricature app, the innovation part was for us to speed up the inference time. It was 0.33 frames per second, and we increased it to 4 frames per second. We reverse engineered a specific part of the pipeline which does the face alignment, which used dlib library, which was used by the authors. But we went ahead and used the MediaPipe library from Google and made a lot of modifications such that it sets properly within the pipeline, and we ended up getting a good performance. With respect to the future work, where we ended up is just creating the architecture and running it on the cloudlets, but we didn't really test out the Magma network component of the whole JIT cloudlet. So in the future work, we would just be interested in knowing how well it adapts to the network component of the JIT cloudlet as well. Thank you. So as far as the application is concerned, it's very similar to OpenArtist. It has the same architecture. On the server side, it's just that the backend is different with a different GAN model, which is trained on a different caricature dataset. And the client interface is also similar to the GrabDail client, which also runs on OpenArtist. So this is the first input image, the user image, and then it tries to adopt the style, and it just created a caricature of me. This whole backend is running on the cloudlet, and it also, you can see the performance is about 4 frames per second. So this is the chatbot which helps the users know more about the music festival. Let me just start. So this is the OpenAI GPT model. Let me start with something that's simple. Hi, how is it going? And it gives me a response, and I'm going to ask, tell me what's happening day one. Yeah, so it gives us an answer saying, on the music festival, attendees will be enjoying performance from Samba Serenade, which is a band which is performing on day one. And I can come here as simple as that. I can just change it, and I can just ask, hi, what is happening day one? Yeah, it gives us a similar answer, but most of the times it tends to hallucinate. That's right now it gave us a good answer, but this is because it is not fine-tuned well enough. But as a future work, we can adopt it, and then it can be made as efficient as the GPT-35 Turbo model.